Okay, let's start. So for today's lecture, we'll continue talking about Ruby on Rails, and this lecture will be the last lecture for Rails, and from next lecture we'll move on to the front end or the client side JavaScript. So for today, again, we'll have two parts. For the first section, we'll go through the videos, finish the last pieces that's related to Rails, and for the second section, we will talk about the homework for this week, and we will use the homework also as a practice. So we'll have the practice session, and basically for this week we'll practice a bit more on Rails. And when we get to the practice session, I will explain more what we're going to do. Okay, so before we get started with the videos, I do want to have a quick review on what we've talked about for the past 2 weeks, specifically on Rails. So again, as we mentioned, Rails is a opinionated web application framework. It uses the MVC design pattern, which is actually a very common pattern we see in web development, and it actually works pretty well in terms of most of the conventional web applications. So then, for people who are not familiar with web dev yet, basically by agreeing to this MVC pattern, we get the benefit of have cleaner code, and because most of the web frameworks are built on top of the assumption of the developer will use MVC, so a lot of features that comes with the framework we could use as long as we agree with the MVC. And then, although we've talked about different aspects of this pattern, and some of the stuff that's offered by Rails, like in last lecture we looked at AOP, and then a week ago we talked about active record or ORM. These are all powerful tools or design patterns that helps to better organize the code. And that being said, usually when we design or plan a system for a web application, assuming it can work with MVC, then what we do first is usually figuring out the data model that's needed behind the application, or in terms that we've used in the course, that's resources, different resources, like user will be a resource, or user, it could be a model, and like if it's a publishing application, it could be like article could be a model, or it's a resource, stuff like that. And then once we finish modeled the data or figuring out all the resources, then the next step would be start implementing each page by creating a route, and then creating a corresponding controller action, and then write the view template for the action. So that's the typical process for developing a web application. um, based on a MVC pattern. Of course, there are other ways to develop web applications that are not necessarily MVC, but it's just not what we will discuss in this course. And typically, like 90% of the application, it should be fine. You should be doing perfectly fine by using MVC. Okay, so that's a quick review. So even though we heavily talk about Ruby on Rails in this course, please remember Ruby on Rails is really just an example we're using here to help you understand the principles and the design patterns behind software development or developing web applications. So instead of course, we will do practice and then hopefully you can get more familiar with Ruby on Rails, but the same principle can apply to other frameworks and even some other applications that's not necessarily web-based. Alright, so that's what I want to mention before we watch the last bit of videos related to Rails. So yeah, please remember, in this course we're trying to talk about to help you understand the principles. Although we will use these frameworks, these tools as an example, but hopefully you get the point. All right, let's get into the videos.
So the goal here is to provide a syntax that if you arrange your tables along the lines of that previous example, then it gives you a very sort of elegant Rubyistic notation for managing those associations. And in fact, for the most part, once you've set it up so that the tables have the correct keys, you don't really have to worry too much about it after that. It kind of just works. So here's how it goes. Within your class that derives from active record base, so we're going to go for the example that we did before where we could say that a movie has many reviews. Here's what you say. Movie has many reviews. Isn't that the most beautiful syntax ever? That's it. You're done. Well, you're not really done, because this assumes that, in fact, you have a reviews table, and that in that reviews table, there is a foreign key called movie ID. So this mechanism is set up so that if you've set up your tables correctly along the lines of the question we just did, then you get some really nice syntax for talking about movies having many reviews. And by the way, in the other class, the review class, I can also say the review belongs to a movie. And this doesn't change the tables in any way. It's the exact same setup, but I'll show you why both sides of this are useful. And by the way, if you have trouble remembering, like, where does the foreign key go, this is the mnemonic that I use. That when I'm declaring relationships, if a movie has many reviews, which one gets has many, which one gets belongs to, the foreign key belongs to me. So if I say that review belongs to a movie, because that's how a movie can have many of them, a review belongs to a movie, then the review table is the one that's going to have the foreign key back to the movies table, not the other way around. So this is just like my little way of remembering this. Maybe it will help you. OK, so what does this look like? So as we've seen, the review table gets a foreign key that has the primary key of the movie that review is for. That allows a movie to have many reviews. So now, if movie is an instance of an active record movie, I can actually say movie.reviews. And I will get back an innumerable collection of all of the review objects that are reviews for that movie, because Rails will have done this join internally, right? It's going to look at the movies table, to look at the reviews table and pull out all records where the movie ID value matches the ID of movie, the receiver of that method, right? I say that it does it lazily, which just means that the join and the query are not actually done until you try to retrieve something from the collection. But that's a nicety. Not only that, if I have a review, I can say review.movie to ask the question, what is the single movie that this review is about, right? Because remember that a movie has many reviews, but a review belongs to exactly one movie. Hence, singular versus plural in the method calls, right? They sort of reflect what you expect. One of them is you're talking about a collection of owned objects. The other one is you're talking about a single owning object. Okay? And this does the reverse thing. If I have a review, then basically, if I look at the movie ID field associated with that review, I can now go back to the movie table and ask which movie is it associated with. So I can actually go in both directions. Right? Syntactically, has many gives me this one, and belongs to give me this one. It doesn't change what's in the tables, but it basically gives Rails a cue that if I say review.movie, I am saying that the review has a foreign key to the movies table, and if I look up the movie whose key matches that FK value, that will be the movie that that review is about. Now, you do have to add the fields yourself. And we've already seen how to use database migrations to change the schema, to like add and remove columns from the tables. So the one thing that isn't sort of purely automatic is you have to make the tables look right. You have to know which table has to have a foreign key in it, and you've got to have a migration that sticks that foreign key in there. And here's what that migration would look like. So if we were creating the reviews table, and this is the migration syntax that you've already seen, the reviews table is going to have an integer field, which is the number of potatoes. And here, I'm going to actually give you a preview of a more complex example. I'm going to put two foreign keys. I'm going to say, I want a foreign key that references the movie table, and I want a foreign key that references the moviegoers table, which we haven't created yet, but we're going to use it in a future example. So if I ran this migration, this is kind of the schema that I would end up with. I have three tables. As always, every table has a field for the primary key, the ID. Sorry, that's a typo. I will fix that. There should not be a, let me fix that right now. That's just super confusing. Hold on. OK, sorry about that. So if I actually run this migration, here's what I get. Three tables, each with a primary key, which is ID, as always. But the reviews table also has two foreign keys. One of them refers back to a movie. One of them refers to a moviegoer. So I'm actually taking our example one step farther and saying that a review not only is associated with a specific movie, it is also associated with the specific moviegoer who wrote it. Okay? And I'm going to use that as the basis of a future example. But this is to show essentially what the migration looks like. Right? This is the part you have to do manually. You have to say which foreign keys you want in the table. And when you say references, what you will get is a field whose name is whatever it references _ ID. Right? That's just Rails convention for how foreign keys are named, which you should follow. OK, so questions about the migration? It's just like any other migration you've seen, only instead of specifying data fields, we're now also able to specify foreign key fields. Right? So it's important to understand that the structure of the table working together with has many and belongs to is another one of these leaky abstractions. Right? Has many and belongs to, if you haven't defined the appropriate foreign keys, Rails doesn't really have any way of knowing it until it tries to do the database query and it says, for example, hey, wait a minute, you're asking for movie.reviews, but the reviews table doesn't have a movie ID field in it. Right? What's the deal? So you still have to understand how the abstraction works in order to use it. But if you don't abuse it, it provides you some pretty nice functionality. Now you can say things like this. Right? If you have a movie and you ask for movie.reviews, you'll get an enumerable collection, each element of which is a review object, an active record review object. They will have been pulled from the database for you. You can also go the other way. If you have a review object, you can ask review.movie, and you will get an instance of the active record movie object, which will have been pulled out of the database for you. You can add new reviews. So I can start out with a movie, and on the collection of reviews, I can either build, which doesn't yet save it, or I can create, which saves it in place, a new review for that movie. How nice is that? One question is, what is different between just calling movie.new or movie.create? What is different about the way that this review object is going to be built if I say movie.reviews.build, movie.reviews.create, as opposed to if I just said movie.create without the intervening reviews? What does this allow to happen? The create saves it as well. So it's true that the difference between these two lines is this will just sort of create it in memory without saving it in the database. This will also save it in the database. But let's say just comparing movie.reviews.create with movie.create. What would be the difference between those two calls? Sir?
So like movies.reviews.create, it probably creates like a review object rather than a movie object because you need to make a new review and then add that.
You're right, and I misspoke. You're right, and what I should have said was, we can edit this out in post. What I should have said was, how is movie.reviews.create different from review.create? That's what I should have said. Sorry about the confusion, ladies and gentlemen. How is movie.reviews.create, which is going to create a review, totally true, but how is that different from just saying review.create? What crucial piece of information is going to be included here that would not necessarily be included automatically with just plain old review.create? Sir?
Does it automatically add a foreign key entry for the movie?
That's exactly the right answer. So the answer is, when you say movie.reviews.create, yeah, it's going to create a review, but the new review that's being created knows what movie it belongs to. In other words, the foreign key value for movie_ID will automatically be filled in when the sort of template of this object is materialized for you by active record. If you just said review.create, by default, the movie ID wouldn't have any value. Now, you may ask, can you actually say can you say review.create and explicitly specify the movie ID value? Yes, you can do that. But why do it when this is actually more legible and has the same effect of doing it for you? The other subtle reason to do this is, as I mentioned, you can actually override whether the foreign key is called movie ID or something else. I do not advise it, but you can. And movie.reviews.create will do the right thing no matter how you named the foreign key. Whereas review.create, now you're basically taking it upon yourself to know how you named the foreign key. But the real reason is this is just more legible. It basically says, I have a movie, it has some reviews, I'm going to add another one. And the critical piece of information being filled in here is the foreign key of that review is going to be correct the moment the review springs into existence. And by the way, movie.reviews is not only an enumerable collection in its own right, it is also an active record relation, which means you can do most things on movie.reviews that you could do just on an individual review. For example, within the reviews, I can say only the reviews for this movie that have a 5 potato rating. So I can essentially attach additional conditions onto the end of this, as this is basically acts like an active record relation. Right? So it's not just a collection that you get back. You can actually do a lot of the other things on it that you could do on just plain a review or just plain movie. So good times. Yes?
Can you do like multiple relational tables? So let's say like you had, I guess you kind of brought it up, but two tables that have nothing in relation to each other, but you have an intermediary table that have a relation to both. Can you form kind of like a relation? Yeah.
Yes. So the question, I'll paraphrase the question. When you have, like in the previous picture that I showed, where there's a table that has pointers to two other tables, but those two outer tables have no relationship to each other, can you essentially navigate through the middle table? And the answer is yes, and that will probably be the first thing we talk about Thursday, because I don't think we'll have time today. But it is called a through association, and it's exactly what you said. And it allows you to ask questions like, who wrote all the reviews for these movies? And you jump through two tables to get to it. So we'll talk about that on Thursday, but good preview, thank you. Okay, so kind of where are we in terms of associations? So to add a one-to-many association, right? So what's one-to-many? That's like movie has many reviews. There's one owning object, and there is a variety of owned objects. So in the owning model, so in our case, the movie model, you put has many whatevers into the active record model file, into the definition. And in the owned model, which in our case was the review, you could say belongs to. Then you have a migration to make sure that the foreign keys that are needed to model the relationship actually become part of those tables. You apply the migration, rake db migrate, as you've done before. And then finally, you just make sure that the changed schema of the database gets reflected to your test database. But in fact, if you forget to do this, Rails will tell you, so not a big deal. Okay? But basically, that's all you do. You decide what you want the relationship to be. you add has many and belongs to in the correct places, and then you create a migration to make sure that the required foreign keys actually exist in those tables, right? And this is the part between steps 1 and 2. This is where it is on you to make sure that they're consistent. If you say movie has many reviews, you're basically making a promise that the reviews table has a movie ID foreign key. And when you write your migration, you had better keep that promise, or things will fail in confusing ways at runtime. Right? Has many and belongs to are not magic. They're just a shorthand that assumes you've set up the tables correctly and then does those queries for you and does all the foreign key matching.
All right, that's the video about association. We'll move on to next one.
OK, so let's talk about through associations. And this actually comes from a question that I think Camille may have asked on Tuesday, which was, what if you want to model the idea of many-to-many associations? How would you do that? Because so far, with all the machinery that we've described, a given foreign key, the foreign key field can only point to one other record in some table. So I sort of gave a preview of this last time. I said, well, what if we wanted to associate reviews with both a movie and a moviegoer? That's simple enough. We already know how to do that. That's kind of what we did on Tuesday. And we say that a moviegoer has many reviews. That makes sense. A movie also has many reviews. And now a review belongs to each of those two things, right? You can ask, given a review, which movie it's about, and you can also ask who wrote it. And I think the question is, this diagram also implies that between movies and moviegoers, there's an implicit many-to-many relationship. In particular, you can imagine asking the question, all of the movies reviewed by some moviegoer, right? So one moviegoer to many movies. But you can also imagine asking, for a particular movie, all of the moviegoers who reviewed it. So if it's one-to-many that way and it's one-to-many that way, then it's really many-to-many. So how do you model that? So this is how you set it up. But how do you actually elegantly ask that bottom question? And this is an extension to has many called has many through, where besides saying moviegoer has many reviews and movie has many reviews and the belongs to, so we still say all those things, but we can also say we can also say that a moviegoer has many movies through reviews. This is about the coolest thing ever, because basically what it says is there's not a direct relationship between moviegoers and movies, but if we essentially traverse from the movies table through the reviews table, from there we can get to the moviegoers, right? So if a moviegoer with some ID, we can certainly find all of the reviews that match moviegoer ID. And for each one of those reviews, we can grab its movie ID and pull out the corresponding movie. So what you end up with is being able to set up an association that actually works the same way in both directions. Because we can also, for the same reason, right, it's symmetric, we can say that a movie has many moviegoers through reviews. Now again, this is analogous to, when do you use the one going this way versus the one going the other way? It's a matter of what the app wants to do. Maybe you only care about traversing the association starting from moviegoer and going to movies. In that case, you don't need the bottom one, or vice versa. But understanding it, in terms of what it does, it's really constructing the query for you that does a three-way table join, right? So it's joining the moviegoers and reviews on matching with moviegoer on ID, and further joining that whole thing on movies matching movie ID. So it constructs the entire query for you and allows you to just say moviegoer.movies, and what you get back is, given a moviegoer, an enumerable collection of all the movies they reviewed. And you can also go the other way. Right. So a really, really nice facility for writing queries that otherwise, if you were just kind of doing these in raw SQL, you would be doing essentially a three-way join with foreign keys. So what does that look like? If you care about SQL, if you're like if this is the world that you come from, because in the past you've written apps where you've had to deal with databases directly, it usually looks something like this, right? You have oops, I forgot this. I don't know why there isn't a select there. There should be a select somewhere. But basically, you're doing a three-way join between moviegoers, reviews, and movies on all the foreign keys. And if you don't know SQL and you don't know the join syntax, you don't need to worry about it too much because, as I said, you will very rarely have to deal with this level of syntax if you're using the active record associations mechanism. But the sort of, the key idea that comes out of this example, sort of if we go up a level from this, to me, the key idea is this, that if you were trying to model a many-to-many relationship, think about what the relationship is and model that. So instead of thinking about, well, if a student has many courses, but a course can also have many students, how do I model the many-to-manyness? Ask the question, is there an object implied by the relationship between students and courses? Right? So I could imagine saying, well, OK, let's call that an enrollment. An enrollment is the idea of a student having a relationship with a course. And by the way, another good reason to model that relationship separately is you can capture other information about the relationship. For example, it's not just that the student is enrolled in a course. Now you could also, if you want, capture things like, was there a date on which they enrolled? Or did they have a priority enroll? Or did they come off of a wait list? Things that are not properties of the student nor of the course, but properties of the relationship between the student and the course. So this is why, even though there's a mechanism that allows you to do pure many-to-many associations without modeling the intermediate relationship, I don't really cover it because it is very rare that the only thing you care about is the many-to-manyness. Usually you end up caring about other things about the relationship as well. And if you model that thing, the relationship, as its own entity, now you can use that has-many-through mechanism. Right? So each side of the has-many is just a simple one-to-many association. Has-many-through lets you traverse it in both directions. Another example, if you're building a social networking app of some kind, and you want to model the concept of people having friends, you can actually do a self-join. You can say a user is friends with many other users. So what does that mean? OK, well, again, is there something that we can extract that is the concept of the relationship between the entities? OK, well, we could call it a friendship. And now, again, you can annotate a friendship with when did the friendship start, or how many, I don't know, how frequently they communicate, things that are about the relationship and not about the principles. And yes, in case you were wondering, Rails does have a syntax for saying something like a user is friends with many, or a user has many friends, but friends are really just things that are in the user's table. So there are ways to do self-join relationships, and I'll leave that level of detail to the other videos and to the textbook explanation. But the basic idea that comes out of this is the same thing in all of them, which is when it's many-to-many, think about what modeling the relationship means, and then figure out your schema and the way that you're going to use associations to capture that. So all of those things having been said, so I could say something like new review equals, so let's see. So if I have something like that and something like that, I have a couple of choices. I could say movie.reviews.build and pass some parameters, after which I could say, I could do that. Or conversely, I can there. OK, so as a follow-up answer to the question, what's the high-order bit of this slide? The high-order bit of the slide is manipulate objects, not IDs. Right? The purpose of the active record abstraction is to allow you to work with a graph of objects rather than wiring into your code the details of foreign key naming and stuff like that. So how do you build a review that has both a movie and a moviegoer associated with it? I could, if I have a movie in hand and a moviegoer in hand, I could use either movie.reviews.build or moviegoer.reviews.build. All right? So this will get the correct foreign key association for the movie into the review. But then I need to manually assign the moviegoer to get the other foreign key. Or I could do it the other way around. Or I could even do, let me mirror, and I'll live code just one more thing. Make this a little smaller. I have another choice, which is that I can just create a blank, a new review with whatever parameters I wanted. Oh, here, we'll use the magic of copy-paste. OK, so I could do that too. graceless for live coding, but okay. So I can also do it purely this way, right? I can just create a review that only has the review parameters in it, but it's not yet associated with either a movie or a moviegoer. And I can then manually grab one or the other. And basically, any one of these three that I call save on will end up saving all of the modified objects, right? So all of the tables that need to get modified will get modified in the right way. And that's the part that some people find a little bit non-intuitive, because if you're accustomed to thinking of, OK, well, when I create this new review, which tables are getting modified? The only table that's actually getting modified is the review table. But if you do this set of steps, or actually any of these sets of steps, and then you say movie.save or moviegoer.save, because there's a relationship now between the review and that movie or that moviegoer, the save will have the effect of causing the review table to be updated too. So it allows you to a certain extent to think in terms of a graph of objects instead of thinking in terms of what am I updating in which table. OK, so another question was, what if you did moviegoer.reviews.create, which has the effect of both building the review in memory and saving it into the database, and then separately assigning whatever the other foreign key is, and then saving it again. So here is yet another alternative for doing this. I can say moviegoer.reviews.create. And in fact, so because I'm using moviegoer as the build, I'll get the foreign key for this sort of for free, but I won't get the one for a movie. So I could actually just say this. I think the question you were really asking is whether you could say that. Make it big again. OK, so I think the question you were asking, sort of bare bones, is could you do the bottom one, where as part of the create call, I can just pass directly the foreign key that I want. You can do that, but again, you actually don't have to. You can just pass the actual object, and the correct foreign key will be extracted from it. So there are many ways to skin this particular cat. And you'll probably see some mixture of all of these in the different apps. Now, I will say this. The one potential issue you could run into when you try to do it this way, when you're trying to do the create in place, and by the way, I think if I substituted build instead of create, this would still apply, right? You could do it with build without saving it in the database right away. The issue with doing a create, which causes an immediate database save, is if you remember last time we talked about validations, one kind of validation that you can declare is for a review to be saved, it must be associated with a moviegoer and with a movie. If you have set up your validations to say that, then this will fail, because at the moment of trying to save it, you're missing one of the foreign keys. But if I used build instead of create, and then I did a separate save step, then it would work. Yeah, these are all method calls, right? So reviews is actually a method that gets defined for you on moviegoers by virtue of using hasmany. And reviews is itself an object that can accept methods like build and create. So every a.b.c, they're all method calls. So remember when you defined, remember in plain old Ruby objects, before we did active record or anything like that, that you can define methods whose name ends in equal sign. And it's a setter method, it's a mutator method for an attribute. That's what these methods are. So there's actually a method called moviegoer equals, which is defined on reviews because reviews belong to movies, right? So the moviegoer equals, movie equals, those are actually method calls that are defined for you by using has many or belongs to.
All right, that's the video about through and has many through and many to many relationship. How to model it in active record. We'll get to the next video.
So far we've just covered how do you actually manipulate and express associations sort of at the level of active record models. But we don't have just models. We also have views and controllers. So a question is, what support do you get in terms of your controllers, your routes, your views, and so forth for representing these same kinds of relationships? Right? And this is kind of related to the question that was just asked, which is when you're creating a new review, how to keep track of the movie and moviegoer with whom it'll be associated sort of in terms of the model view controller flow. Because you need to know this stuff at the moment you do the create. So we already know that if we declare movie as a resource, we get route helpers like new movie path that will resolve to the correct RESTful URI. Remember that's that one line we can put in the routes file saying, please give me all of the standard RESTful actions on this object. But now life is a little more complicated because we would like movies to also be associated with other things. And it turns out that you can automatically generate routes and other support, route helpers, and whatever that mirror that relationship. So instead of just saying resources movies, suppose we say resources movies, and then we have a do block inside of which is resources reviews. This basically says reviews are also a resource, but they're a resource that belongs to a movie in the sense that it's meaningless to talk about a review without talking about which movie owns it. So I am nesting the resource of reviews inside the resource of movies. And now Rails will build for us additional route helpers and all of the other RESTful stuff that reflects that relationship. Because now the routes will allow us to express right in the route itself that not only is this a review, but it's a review associated with a particular movie. Let's see how that works. If we added that line in our routes file, and then I ran rake routes, which displays all of the routes that are defined, notice what's different now. All the routes that have to do with reviews have the word movie somewhere in front of them, because we've nested the review resource inside the movie resource. It's not just a review path, it is a movie review path for some movie and some review. Right? So now there's actually two things that are going to come out of the route that are stuck into params for you. You'll get, in the case of looking at edit movie review path as an example, part of the URI will be the owning movie ID, and part of the URI will be the ID of the primary resource in question, which in this case is a review. So as before, params ID will refer to the primary resource that the operation is about, but you'll also get the ID of the owning object, basically what the foreign key would be in the association. So this lets you construct a route and pass the route around. Think of why this is important. At every step in a controller where you're manipulating a review, and you need to know what movie it belongs to, the route itself is carrying that information around. Right? It's sort of carrying it around for you for free. So that also means excuse me, that when you generate these paths, right, no longer are you just saying, I need the path for a new review. It's the path for a new review that would belong to a certain movie. Right? So the syntax of the routes is very similar to what you've seen, but in addition to the ID of the primary resource, the route can also now include the ID of the owning resource. You do not have to do it this way. You could just have movies and reviews each be a flat resource and have your own mechanism for essentially passing around what the movie ID should be. But it's, I think from a RESTful sort of philosophy point of view, it's much nicer if just looking at the route basically tells you a review is a thing that is associated with a movie in a way that doesn't make sense to separate. Right? We never talk about a review without also talking about which movie is it for. And if you're wondering, yes, you can actually have double sets of routes where you can get to the same review either through its movie route or through its moviegoer route. You can declare them both. So what does it look like to use this stuff? Here's what the revised controller action might look like for creating a new review. So if we're in the create action, up there on the post, that's a reminder of how we got here. Right? That's what the route would have looked like. For creating a new review, the review itself does not yet have an ID because we haven't created it. But the route includes the ID of the owning movie. Right? And that is available from the route as params movie ID. So that's what's going to give you the movie from which you're going to build the review on top of. Right? In this example, I am not yet dealing with movie also belonging to moviegoer. I'm just dealing with the relationship between movies and reviews. So I create the new review. I know what foreign key it's going to have because I have already easily looked up which movie it's going to belong to because the route itself carries that information now. Very cool. And now, as usual, I can try to save it. If everything goes well, then I can redirect to somewhere. Where am I redirecting to? Well, in this case, I've chosen to redirect to the list of all reviews for that movie. Remember that in a non-nested resource, I can't cover both of these, but if reviews were not nested inside movie, reviews path all by itself would just be the list of all reviews. Now that it is nested inside the movie resource, movie reviews path is all the reviews for that particular movie. Which movie? Now the route helper needs an argument, right? So it's the same. Just like with simple resources, you can go in both directions. You can say, give me the RESTful routes for doing various things to reviews, but now they're always conditioned on belonging to a particular movie, which means that I need to tell the route generator which movie it's about. Was there, yes?
What if I wanted to, like, what if you did it this way with the association, but like you still wanted to get all the reviews listed out regardless of the movie? Like, what would you do?
OK, so the question was, suppose you do everything I just said, but you also want the ability to just list all reviews, like all reviews ever, regardless of which movie they belong to. So there's a couple of things you could do. One of them is in your routes file, you could separately say resources reviews. So it's perfectly legal to have multiple routes that end up mapping to the same controller action. You could also just separately define a one-off route, right? So in addition to having your reviews nested inside the movies, you could also separately define a route. You could call it something like, all reviews. And all it does is route to an action that just gets all the reviews irrespective of anything and doesn't care about the movie ID. So there's a couple of ways to do it, right? The goal of the RESTful routes is not that they solve 100% of your route problems, but it's that they cover the most common operations, even in cases where there's a relationship between the objects, right? That's the thing that's new here is you can still maintain the idea of basic RESTful operations, but not lose the idea that there's a hierarchical relationship between the objects that you're referring to. So that's basically the answer to your question. A couple of different ways to do it. OK, so does this make sense to people? Do we understand why in this case we need to pass, to go back to the list of reviews for the movie that we just built a new review for, why we have to pass the movie as an argument to the route helper, right? Because the route that is going to result from this is going to look something like /movies / the ID of this thing / reviews. And then when the index action in the controller gets that route, it can do the same trick. It can pull the movie ID out and say, OK, now I can just say movie.reviews of this, and that's the list that I'm going to display. What about building a new movie? So somewhere you're going to have a form the user fills in, or a new review, excuse me. Somewhere you're going to have a form where the user fills in the number of potatoes and some other stuff. So again, here's a reminder of what that route typically looks like. We'll grab the ID of the movie for which we want to build a new review, because it's part of the route, which is great. We can set review to be a new copy of a review. So the review doesn't have anything in it except for the correct foreign key. That will allow, which by the way, this line is basically functionally equivalent to doing this, right? And I'll explain in a moment why you would do it this way. But essentially what we're doing is we're going to create a blank copy of a review that's going to serve as the basis of the fill-in form. The only thing about it that is not blank is that it will have the correct movie ID in it. And the route, once the template is actually rendered, there's a form that's going to be submitted. The submit on that form is going to have a submit button that creates the post route with the movie ID embedded in it as well. So it's all of the same mechanisms that apply to a flat namespace resource, but they're extended so that you can have one resource nested inside another. The routes, the submission forms for the routes for the submissions of forms, basically all of that stuff gets extended in the same way. Why am I doing this? An idiom that you will see in a lot of apps. Suppose that the user fills in that form and movie creation in the create action ends up failing. You actually want to be able to, in the create action, redirect back to the same form that the user filled in. Doing something like double or equals means that if there were already values the user had filled in for the review, they will persist. So the user doesn't have to fill in all of the stuff that actually was legal. Okay, so you'll often see one of these two lines as an idiom rather than just assigning to a blank new review. It'll assign it only if it hasn't already been assigned. It's kind of a standard way to recover from an error, but I wouldn't worry about it too much. The main thing that I want you to get from this is that every action, create, new, et cetera, is now extensible because we know the ID of the owning resource. That means that we can populate the form submit button properly, and that the movie ID value will sort of always be carried around. Right? That's the main idea. Another idiom you will see, we talked about before filters or before actions on controllers. If you know that every operation you're ever going to do on a review counts on having this nested route with a movie ID in it, you could actually write a little function like this one, whose only purpose in life is to set at movie to whatever the movie ID is in the route. Right? So this is expecting the route to be in this nested format. And now just say, run this lookup movie action before every single controller action. Basically, that allows the controller actions to assume that at the moment they are entered, at movie has already been set to the owning movie of this review, and they don't have to do that themselves. Right? So when we introduced before filters on Tuesday, the main motivation for them was preventing a controller action that shouldn't run. But this is another thing you can do. If the controller actions are inside of a controller that manipulates a nested resource, the before action can save some work by looking up the ID of the nested resource. So you can do that. This is an idiom that you'll see as well. OK, so basic questions about how the routes and controllers. It's like I said, as you start seeing and playing with this code, you'll get more comfortable with it. But it's really just a straightforward extension of how routes already work for simple resources that are not nested. OK, and then the last thing is, what can you do in the views? So we've already seen that there are these nice form tag helpers where you can pass the RESTful route that becomes part of the form submit. So same thing here, except that now, if we're editing a review, it's not just the we don't pass only the review instance to the route helper. We also have to pass the movie instance, because we want the submit to actually include both of those things, right? So if we have a movie review path, then it implies that there's two resources in question here. The primary one is the review itself, but the owning resource, the movie, is the one that we want to sort of keep in the URI, be able to keep passing its ID around. So the form tag helpers, the same way that you use them for doing basic operations on a simple resource, they're extended here. You just need to pass them the additional argument. All reviews for this movie looks like movie reviews path, but now you need to pass the movie object in order to tell it which movie to get the reviews from. And as with all these helpers, you don't have to do it. But if you use these mechanisms consistently, they actually save you a lot of lines of code, because they sort of help with the invariant that anytime you're manipulating a review, you sort of have to have the movie be carried around with it. Otherwise, you have no way to construct the submit actions. You have no way to construct the index action. So if you don't use the helpers, you leave yourself vulnerable to the possibility that you need some other way to pass that information around. Right, so as with so many other things, I realize we're throwing a lot at you in a short amount of time. But if you're browsing either the legacy code for your own project, or if any of you have actually tried to look at the open GitHub repos for some of the past projects, you'll see this all over the place. If you want to look for some examples, the easiest thing is to find projects where the routes.rb file has some nested resources in it, and then take a look at those controllers and see how they manipulate the nested resource. And it has to do with referential integrity. We didn't talk about this. So we had talked about the idea of X has many Ys, right? And we kept going back to our example of movies and reviews. And we never asked what happens if you delete a movie and that movie had some reviews already associated with it. What should happen, logically, what should happen to the reviews? So from the point of view of using the app, what's the right behavior? And what are the ways that you express that behavior in terms of the code? Now, in terms of the code, what's going on? If you delete a particular movie, then by default, any reviews that had movie IDs foreign key as the key for that movie all of a sudden refer to something non-existent. And you could sort of predict what this is going to do code-wise, right? You have a review, you say review.movie, and you get an error because it's trying to do a database lookup for something that doesn't exist. Which, is, by the way, is different from the review not being associated with a movie. That would mean that its foreign key for movie ID doesn't have any value, and then Rails knows that the movie associated with it should just be nil. But this is actually saying it has a movie associated with it, and then that movie ID gets looked up and it's not found. That is actually an error. And by the way, this is another reason that primary keys never get recycled, right? You wouldn't want movie ID to refer to some new movie that happened to inherit the ID of one that was deleted a long time ago. So what can you do? It depends on what the app is supposed to do, but if the goal is when a movie is deleted, all of its owned objects, in this case reviews, should also be deleted, you can add, when you say has many reviews, you can add this qualifier that says dependent destroy. That means that if the movie gets deleted, automatically without you doing anything, all of the reviews associated with it also get deleted. So that ensures that you will never have a review whose movie ID has a value that corresponds to no existing row in the movies table. That's one possibility. Or perhaps the possibility you want to keep those reviews around, but you want to avoid having the review try to dereference its owning movie and getting an error. In that case, you can add dependent nullify, which basically means when a movie is deleted, any reviews that have movie ID as that movie, those keys will be nilled out. So you can still access the review, but if you say review.movie, you'll just get back nil, not an error, right? So the correct behavior depends on the app. You're probably asking, if you say neither of these things, which behavior is the default? And I'll tell you, I don't remember. But if it was me, I'd look it up. The safe thing is to have one or the other clearly marked, because that also makes it clear when someone is reading the code, right? In terms of cognitive load, it's nice to know what this actually means. By the way, there is a third possibility, which is you never allow a movie to be deleted at all. In that case, it doesn't really matter which one you do, because the problem that this solves will never arise. But in most cases, it's worth worrying about.
All right, that's the third video. A comment on the last point he has made. What I typically do for deletion is I never allow a hard delete when developing a Ruby on Rails application. Instead, I just, if a deletion is required for the functionality, then I would implement something like a soft delete, which means adding an additional field to the model that needs to be deleted, and say like the field is like deleted, which is a Boolean field, or it could be like archived, which is also a Boolean field, and then make sure in terms of the default scope of the model, set it to like deleted is not true, or deleted is false, to make sure the deleted items never gets returned in a controller or view, but you always have the chance to just find that deleted record in the database, and then by switching that field you could just recover it, because many times like actually user deletes stuff by mistake, and before you have a backup mechanism in place for a system, like something like a soft delete could be really helpful, and then even if you have a backup mechanism in place, to recover some data from a backup, it's not an easy task usually, and then typically you don't want to roll back to the backup point, but rather just find the related data in a backup copy, and then just reapply it on top of what's already in there. So just my piece of the advice. Just from my experience and what I see, just try to just don't allow user to delete anything, unless like it's like super sensitive data or something about user privacy, that kind of thing. Otherwise, always implement a soft delete if a deletion functionality is required. Alright, we'll move on to the next video. Oh, and by the way, just a recap. So that's so the previous two videos we talked about associations. Basically, different models can depend or can relate to each other, and then this video is about for this kind of nested or associated data, how we do it in terms of the routes, the controller. Right, we'll move on to the next video.
Moving on, we're sort of continuing our tour of how to dry out applications, and a really neat feature that they really got right in Active Record sometime late in Rails 2 is the idea of having reusable scopes. So one way to motivate why you'd care about scopes is suppose we wanted to think about customizing associations, right? We already have an association between movies and reviews, but there are certain common cases that we'd like to capture as sort of reusable queries. So for example, a movie might be appropriate for kids. Well, you could just tell that from the movie's rating, whether it's PG or PG-13. But movies that have at least some number of reviews, or at least have some average score across all their reviews, and then what if you wanted to combine those things, right? Because movies with at least n reviews, well, clearly that requires some sort of a join. You have to look both at movies and reviews to figure that out. Whereas things like movies appropriate for kids, all you got to do is look at the movies themselves. So is there a way that you can sort of express some of these reusable queries in a way that you can actually put them together like building blocks? And in fact, scopes allow you to do exactly this. So we can, for example, let's, if we defined, this is the code we would like to, we'd like to be able to write is movies or movie.forKids would return just movies with a certain rating, but we'd like to be able to chain onto that, for example, movie with good reviews, maybe above average review rating of 3 across all the reviews for that movie. Or maybe we could define something like a movie with many fans, meaning a certain minimum number of moviegoers have written reviews for it, and we could define recently reviewed as the last review for this movie was posted within some date. So the idea is that the reviews can have things that are time varying. In other words, the idea of recently reviewed obviously depends on when you evaluate it, right? It's something that has to be evaluated at runtime, but you'd still like to capture the reusability of these queries in a nice declarative way. So let's take a look at some code that allows us to do just this. Okay, so here's an example of how we could do something like what I just said. So I've added 2 things to the movie model here. I've added 2 scopes. One scope is called for kids. And by the way, you should already sort of, the metaprogramming bells should be going off in your head, right? Because I'm passing a symbol, and the symbol is going to become basically the name of a class method. So one kind of scope is where I'm just declaring conditions of the same kind that I would pass to where. You can think of it as I'm almost capturing the desired behavior of a where clause, but I'm using a shorthand so that I don't have to do it over and over again. But the more interesting one is something like this. Here's another kind of scope where what I'm providing is basically a function, in this case a function of one argument, so I can pass a cutoff score for the average review. And what's going to happen in this lambda expression is that I'm joining the movie table with the reviews table. I'm grouping that by the movie ID, and then I'm taking the average of all of the reviews relative to this argument value. Right? So first of all, why is this in a lambda expression? It's because I need to be able to evaluate this for a particular argument value, right? I need to be able to instantiate at runtime a version of this procedure that will have sort of embedded into it the right value for the cutoff, so that I can do things like with good reviews parentheses 3 and have the right query synthesized. So these are 2 different ways that I can set up reusable scopes. And what's interesting is that these are stackable. So in this terminal window, which I'm hoping is big enough text for you to see, except the terminal window is getting unmanageably large there. So I just cut and pasted that code into my terminal window, which means that, what did I call it? For kids? So that's a legal query, and it actually returns the right legal thing. Now, I haven't populated my database here with any reviews, but it's still legal. Okay, what will happen if I hit return right now? Why am I going to get an error? Anybody? Why am I about to get an error? I haven't passed in an argument, right? The way that I defined the scope with good reviews is that I defined it as a lambda expression that expects 1 argument. So sure enough, wrong number of arguments in my block. No problem, I can fix that. Now what did I get back? Well, I got back the empty collection, which is not surprising because I don't have any reviews. But what I was trying to illustrate is that I can stack these 2 things. In fact, I can stack them in the other order too. Now, I'll still get a blank because I haven't populated with any reviews. But what's interesting is to ask the question, where did the query occur? Right? So I see a query going to the database here. You'd think that that means that the query is happening at the moment that I type the command line. But suppose I do this. What just didn't happen? I didn't do a query, right? If we assume, as is indeed the case, that when we see this printed out in Rails console, it means that the query actually went to the database. This time, no query went to the database. So what's the difference? What did I do the second time different from what I did the first time? Ready for a clue? In case you missed it. What's going on? Is it lazy or is it not lazy? Lazy or eager? Does anyone want to take a guess? An informed guess?
The movie gets returned when you're just running that one statement when you sign it. So when it returns the movie, it then evaluates the query. Whereas if on the example where it doesn't run, you're actually just returning nil. So you don't actually evaluate at the end.
So it's tricky, but what's happening, you're on the right track here, right? When I do this example, what does the command line interpreter for Ruby do every time I type in an expression? It prints the value of the expression, right? So remember we said that queries are lazy. The query doesn't actually happen until somebody tries to consume the value, but the interpreter is going to consume the value because it has to print something out. But when I do this, m gets assigned, and the only thing the interpreter needs to print out is the value of the last expression evaluated, which is nil. So no query actually happens in that case. Right? Now, did I do this just to sort of show off some Ruby trickery? No, there's a really good reason for doing it this way, right? Coming back to the idea that we're using these higher order functions that we define, and we don't actually, we can compose these things together in ways that allow us to do the query in the future but doesn't happen right away. I'm giving you a preview as to why you're going to care about this. One thing we're going to talk about when we get to operations and scalability and performance is that a surefire way to have a bad day at the office is to have your app bottleneck because your database is getting overloaded. Right? We've already talked about you can't sort of horizontally scale your way out of the database problem like you can with the logic tier, with the presentation tier. So wouldn't it be nice if there was a way for you to write code such that in your controller method, you have things in your controller method that look like they're queries, and in your view, you have stuff that looks like it's just printing out the results of the queries. Well, now we know, because we've gone through this little example, that the thing in the controller method that looks like it does a query doesn't really necessarily do it. It just sets up an object that could do it, and then in the view, when you actually try to render that value of that object, that's when the query happens. So as a preview, where we're going with this is in the view, suppose you could say, around portions of your view, basically check my cache, and if I've already done this query recently, I don't need to do it again. So it's very powerfully, you can have logic in your controller that looks like it's where the query is happening, but because the query is actually deferred until the view, in the view you can actually put logic that says conditionally just render the same view we did last time because we don't have to recompute this. It hasn't changed in the database. So as a preview, it gives you, among other things, a really nice way to do caching. But the real value in this example is that it allows these things to be stacked. Right? And the reason that they're stackable is you can stack as many as you want because no query actually ever happens until somebody tries to consume the first value. That's when the query hits the database. As another preview, one of the design patterns that we're going to look at when we start talking about design patterns in a couple of weeks is their design pattern called the decorator, which means I have a function that does something, but I want to enhance it so that it also does something else. So the way it applies in this example is I have a method that returns movies for kids, but I want to decorate it so that it also is able to filter out only the ones with good reviews. Or it also filters out only the ones that have been reviewed recently. So it still does everything it used to do, but I also want to add a new thing that it does. And I want to do that without modifying the existing code that I have. That's called decorating the existing code, and it's an example of the decorator design pattern. This is a really nice example of the decorator design pattern. We can create a bunch of different scopes and stack them together like building blocks, adding on to existing behaviors and not having to pay the price, as it were, until the view tries to consume the values. So based on that, we should be easily able to answer this question, which is looking at this small snippet of code where we've got some controller logic up here and some stuff in a view down here. Where do database queries happen? Do they happen only in line 3, only in line 6 and 7, in both line 3 and line 6 and 7, or does it depend on the return value of the first scope because we don't know what the second scope is going to have to operate on?
All right. I'll leave that last piece of quiz. It's a small quiz. Up to you to think about that. It shouldn't be too difficult to figure out. And then if you're not sure, you can always actually set it up in a Rails application and try it out. And that code is actually from what we'll see in the practice. Okay, and we'll have our last conclusion video.
Let's talk about other kinds of code, or as I call it, none of the above. Because when we introduced the model view controller design pattern, the idea was that you shouldn't put code in your views, because the only thing a view should do is have enough information for the user to interact with information from the model and give information back to the model, like filling out forms. We also said your controller methods should be really simple, because the controller should be doing the minimum necessary to be the mediator between the views that the user interacts with and the model, which is where the business logic is, that manipulates the actual entities that your app cares about. So, does that mean that everything else, if it's not in a view and if it's not in a controller, does that mean it should go in the model? Hardly. And in fact, one of the sort of early critiques about Rails was that the models become extremely bloated and have all kinds of code in there that is not about the model. Now, what do we mean by that? Well, for one thing, remember that models in Rails are based on this abstraction called active record, which we described earlier in the course. Active record really just says that when you have a data structure that defines a kind of thing that your app manipulates, the storage of that data structure in a persistent storage, like a relational database, happens more or less automatically. When you modify the model, it changes the database. When you're searching through a collection of models, you're doing a database query. That's really the essence of active record. But there's a whole lot of code that goes into a typical non-trivial SaaS application that is not really just about that. And that code shouldn't go in the model either. So where else can it go if it's none of the above? We're going to distinguish at least 3 other kinds of code, playing 3 different types of roles, if you will, in your SaaS application. The first is code that you factor out functionality to keep your main classes slim. Things that are not about the model and how it's stored and the basic operations on it maybe can be factored out and moved somewhere else. Places where you need a little bit of extra help to make the view look nice, but you don't want to put the code in the view. That's one category. A second category is code that will help you dry out other parts of your app, or maybe even dry out repetitive tasks by automating them. And the third kind is code that encapsulates coupling among models. And this is possibly the most interesting category. So let's talk about some examples of each of these in turn. Factoring out code to keep your main classes slim. What are some cases where you'd want to do this? Well, if you Google presenter, as in model view presenter, presenter is some code that helps the views sort of do a better job of displaying complicated objects or letting the user interact with them. So they're related to what the view does, but you don't want to make them part of the view itself, because we try to keep code out of our views. So that's one example of factoring out code. Another example is something that's called a value object. A value object is one where, for example, comparisons of the object are not based on its primitive type. Let's consider, for example, that you're creating an app in which you manipulate ranges of dates. So what does it mean for one range of dates to be less than another or to be equal to another? Or if you have an app that manipulates street addresses, what does it mean for one address to be closer to another address compared to a third one? So these are cases where you can encapsulate logic like that in its own class and call that a value object. When we talk about design patterns later in the course, we're going to learn 2 design patterns called adapter and decorator. And these are cases where you need to add some behavior to an existing class, but have that new thing essentially behave like a member of that class. So what's an example? Let's say you have an app where one of your classes, in fact, one of your models, is about storing some sort of a document. One variation you might want to have on that is, what if the document is encrypted or requires a password to get at? So that's not really part of the document model, because the document model is about how storing the document maps into the database. But you could decorate the document model with, let's say, encrypted document that has all of the behaviors of the underlying document, but allows you to also talk about the idea of it being encrypted. The second category is code that dries out parts of your app by extracting reusable behaviors that can now be used in different classes, like mixed in, or automating a repetitive task. So what are examples of these? One example of reusing a behavior across classes is sometimes called a concern. Let's imagine that you have an app that stores a variety of different objects that have big blobs of text. For example, reviews of movies or summaries of a movie. In Simple Rotten Potatoes app, those are two examples of a place where you might have blobs of text and you'd want them to be searchable. Now, relational databases by themselves don't give you much flexibility in looking up things in full text search, but clearly full text search is a behavior that would make sense to be able to add into either the movie reviews or the movie summaries. So Rails actually provides a way to mix in behaviors through Ruby's module mix-in mechanism. We met that back when we talked about duck typing. And concerns are a way to achieve that behavior in your app. It's a set of behaviors that can essentially be mixed into different models. And what about automations? Well, one kind of automation that comes up all the time in software as a service is when you're deploying a test version of the app for the customer to review, you might want to put some realistic but fake data in there so the customer can see what it's like to use the app, but doesn't have to risk an experimental version of the app mucking up their real data. So a task that knows the schema of the app and can create realistic staging data is a great candidate for automation. And in the case of Rails, Rake is usually the tool that is used to build those automations. What about encapsulating coupling among objects? This is one of the more interesting ones to me because it addresses the question of what do you do for a piece of app functionality that has to touch multiple models? So consider that you have an e-commerce app and the customer is about to finalize their order and buy something. Buying something is actually pretty complicated because it's going to affect the customer's order history. It's going to affect the inventory of the items being purchased. It might affect the revenue bookkeeping. So there might be multiple models or multiple tables that all participate in the single transaction of somebody buying an item. And a service object is a great place to incorporate all of that because you don't want the inventory model to know the details of the order history model. You don't want the order history model to know the details of the transaction and revenue model. So this is a place where you can encapsulate, right? You can put a boundary around, here is some code that actually has to know the details about all of those three things. And service objects usually don't get their own tables. They're usually stateless, but they encapsulate non-trivial logic that usually touches multiple models and has to really know something about how they all work together. That keeps the models from having to know too much about each other. Specific cases of service objects that often arise in software as a service, one of them is a form object. So in the simplistic case, when you start using Rails, when you present a form on a page, that form is usually related to a particular model. But you can imagine a form that touches multiple models. In fact, going back to our simple idea of movies and reviews, you can imagine that if the user submits a review for a movie, not only does that form do something to the reviews table, but you can imagine if the user has specified, a preference or a popularity rating, some other metadata that isn't part of the review, but makes sense to present with the review in the user interface. So now, all of a sudden, you have a form that isn't just dedicated to a single model type. A form object can encapsulate that dependency, so you don't have to sort of put code that knows about model B into model A. A query object, similarly, suppose you're allowing the user to run a query that actually has to touch multiple model tables. That means that the query logic has to know some details about each of those models' schema or schemata. So a query object is another example of a service object because, again, it encapsulates a dependency among multiple models. It keeps all of that dependency information in one place. And I guess sort of another special case is a policy object. So we've got things the user can buy, we've got express shipping, we've got all these options, and there is a question of who is allowed to do what in the application. For example, there's a reporting model, but the user probably isn't allowed to run financial reports if they're just a customer. That would be something that the back office accounting person does. So a model that encapsulates who is allowed to do what under which circumstances so that again, each individual model doesn't have to worry about those policies. It just has to know how to fulfill the functions that are intrinsic to itself. So that's kind of a small zoo of other types of code that if you don't know, if it doesn't feel like it belongs in a model, and you're pretty sure it doesn't belong in a viewer or a controller, here's a handful of choices for what it could be. Where do you put this stuff? Like, where do the files live? Well, there are a couple of cases where convention over configuration tells us the answer. In the Rails framework, the rake tool is the way that you automate workflows and tasks that are repetitive. So there's a subdirectory lib/tasks. That's the natural place for your rake tasks to live. In Rails version starting with version 5, there's a directory called app/concerns where you can put concerns like searchable, taggable, commentable, some of these behaviors that make sense to add to a variety of different model types. What about for the other stuff? There's no specific convention for some of the other stuff, but we highly recommend that you put it somewhere in a subdirectory underneath app. And the main reason for that is when you start your Rails app, everything that's under the app subdirectory gets automatically loaded, meaning that if you put stuff someplace else other than app, you have to go out of your way to load it, and usually you do that by modifying Rails load path. Not a big deal, but it's kind of one more thing to worry about if you don't have to. So the bottom line here is that we know we told you to keep your views free of code and controller methods really thin, but a bloated model is just as much a bad code smell as having code in your views and controllers. So be aware when you're adding something to a model file, ask yourself, is this really a core functionality, a core responsibility of that model? If the answer is no, think about what other kind of code it might be and where you can put it so that you don't pollute the model with more than it really should be responsible for.
All right, that's all the videos for Rails. And we're done with videos. We're done with Rails. Well, in the sense that running the Rails itself, because later down the course we have more stuff that's built on top of Rails for examples. Alright, so that's all the videos. Next we will get to the practice. Before that, we'll talk about homework. So for this week or week 4 homework, again, the basic option is to write a summary and optionally a reflection. However, for this week, the chapter will be chapter 6. So if you're doing this homework option, you probably should have done chapter 1, 2, 3, and we're skipping chapter 4 and 5. So you don't need to read it. It's optional, but still, if you're interested, feel free to read it. Chapter 4 and 5 is primarily about Ruby on Rails. But since for the basic homework option, we're trying to help you learn the principles rather than focus too much on the hands-on coding stuff. So if you choose to go with the basic option to write a summary, for this week, just jump to chapter 6. And then for the hands-on or chips homework option, we're going to do Hello Rails and Rails intro. And here I will show you a quick walkthrough on how to set it up. So actually, if you click on the homework, you'll see links. These two are also on GitHub. I've already opened it in my browser. Oops. Okay. So this is the first homework. It basically walks you through how to start a web application from scratch. The repo itself doesn't have any code in it. It just have a bunch of documentations. It has a README, with the introduction and some other outline of what we're trying to do with this practice. And then if you open the docs folder, you will see part 1, 2, 3, 4, which are the 4 major steps for this practice. So before we get into that, what you will need to do is fork it. Of course, I've already forked it. Go to the docs, go to part 1. Here it will tell you to install Ruby, install Rails, install Bundle, and all that with the correct version. And this is the most important thing, with the correct version. Because this practice was designed actually long ago, it was only tested for a pretty old version of Ruby Rails. So you will have to get the version right, otherwise it will break. So now let me get my terminal here. Hopefully you can see the commands I will write. So depending on your Ruby installation, and most likely if you install it, it's gonna be like a good version. So here, according to the documentation, the specification is any version greater than or equal to 2.6.4 and less than Ruby 3. And I think in most cases by default you will get a Ruby version within that range, so you should be good. But in case something is not right, like you've worked on Ruby on Rails in your system long ago, you might have a earlier version, or you might be using a version that's being used for a current project that you don't want to use it, and you want to have a separate environment for that. Then in that case, as recommended, RVM or Ruby Version Manager is a great tool and a highly recommended tool for you to use. For example, for me, currently that's what's activated on my system is Ruby 2.7.2. Let's say I actually want to use 2.6.4, which actually I haven't installed it. So let me go to a temporary directory. Let me remove what I already have. I will clone it. Okay, so this is a fresh start from the repo, and there's nothing in it except for the documentations. Now with RVM, I will just say RVM list. You can see all the Ruby versions I've installed in my operating system. Let's say I want to switch to, I want to install 2.6.4. I believe that to be RVM install 2.6.4. Right, 2.6.4 is installed. If I run ruby-v, I should be on the newly installed version. If it's not, you can still run RVM list to make sure it's actually installed. And you could run RVM use 2.6.4 to switch to the right version. Okay. And then for Rails, if it's a fresh Ruby install, you can just use gem install to install the right version of Rails. But let's say you already installed Rails somewhere, and then it's a different version. And most likely, if you've already got Rails installed, it will be a different version, because Rails 4.2 is actually really old. Now it's already 6, and even if it's not the latest version, most likely you will have get Rails 5. So in order to use Rails 4, although the bundlers file will handle the right handle the versions for you, meaning including the right versions of the gems for a certain application. But because we're starting a new Rails project, we don't have the bundle file yet. So if I remember correctly, oopsie, yeah, the command should be called bundle init. What happens is it will generate a gem file in your current directory. And then if you edit it, you'll see some basic stuff set up here. Okay, so because we don't want to mess up with what we already have with the current version of Ruby, so we are going to use bundler to install the right version of Rails, and then use the specific version of Rails to generate a new Rails project, which actually have another gem file in it. So we're temporarily using a gem file or the bundler environment to generate a Rails project with the specific Rails version, and then we kind of can discard the current, the temporary gem file we're using here. So go back to the gem file again. It actually already have Rails in it. Just uncomment it, and then by default it doesn't have the version. But we're here. We're going to specify the version for Rails here, because that's what we want. And for 4.2, I checked it out this weekend. The latest release should be 4.2.11.3. And another principle of software development: try to always go with the latest version, even within a major release. So although Rails has already released Rails 5 and 6, if you have to use Rails 4, try to still use the latest release under Rails 4. And in this case, it's 4.2.11.3. Right. Save it. Whoopsie. Press the wrong button. Saved it. Then run bundle install. And you should see that Rails 4.2.11.3 has been installed successfully. Now, if I run Rails-v, because this is a fresh Ruby environment, it by default goes to whatever that's recently installed in the system. But otherwise, if you already have Rails installed for your specific version of Ruby environment, you could always run bundle execute Rails, and it should give you the Rails version exactly matching the gem file. Okay, now we will use this Rails command line to generate a new Rails project. And then if you look at the second section of this part 1 document, you will get this command. So instead of using the raw command, we are preparing it with bundle execute. to make sure we're using the right version of Rails. Okay, then I'll copy whatever that's there. Okay, installed. And we're gonna go to Rotten Potatoes. And by the way, Rotten Potatoes is the example project for this course. Probably you've already heard quite a few times in the videos when the professor talked about Rotten Potatoes. It's basically the example project we're using here. And then let's say if you're indeed developing a project called Rotten Potato, then this is usually your first step by generating a fresh new Rails application skeleton by running this command. And I've already changed my current directory to the newly generated Rails project. And if I print the gem file, you can see it has the specific version of Rails declared as dependency. So at this point, this gem file is no longer necessary. So I could remove that. Okay, and then Rails server, or Rails as in short, to make sure it's up and running. And actually it's not, because we're using the wrong version of SQLite. What's actually has been addressed here. So just downgrade the gem version by editing gem file SQLite 3, specify the version, save it, bundle install. Sorry, not bundle install. Actually, bundle install also works. Or you could go according to the documentation, which is bundle update. It's a little bit different, but for this purpose, it does. Both of these will do the work. Okay, start the application again. Wait. Great. If you see the welcome or get started page, that means you've got a fresh new Rails application ready to go. And then I won't go to the other parts. It's for you to do the practice in your homework. Just follow along the instructions, and you should have a very basic Rails application with some minimal model view controller going on. And the last step would ask you to deploy the application to production. And in this example, it uses Heroku, which is a pretty decent service actually. It really streamlines the deployment for a framework like Ruby on Rails. It has a free layer. It has a free plan. For this course, the free plan should be good enough. So make sure you create an account. I don't think you even have to like enter credit card information, but I don't remember exactly. Yeah, just create an account, deploy it, just go through the step 1, 2, 3, 4, deploy it to Heroku, and then it should generate the link for application, and then submit that link as well as the link of your GitHub repo, and that will be your homework. And that's also the practice for today. And the second practice is the barebone rotten potato application. Um, you don't actually need to do anything specific, or you don't have to modify the code or anything. All you have to do is just clone this code on your local environment and make sure when you run Rails server or Rails S, it will start the application correctly, and you can see that Rotten Potato website by visiting the local environment. So I won't walk through this one here. I will leave it up to you. And once it's up and running, take a screenshot, and that will be the second part of your homework. And then for this course later down the line, we'll have more stuff to do with this Rotten Potato application. So make sure, so this practice, this Rails intro, is kind of the baseline. Like imagining we are starting a new project, and we already have some basic functionality implemented. So so we're teaching agile methodology here. So we're going to iterate throughout this course by adding new features, fix bugs, write more testings into this Rotten Potato project. So this repo here is really the bare minimum or the bare bone or the starting point or the baseline of this Rotten Potato project. Okay, so make sure you get it running on your local environment. Make sure it's functioning just by browsing through the application and even submitting some new movies or dummy movies. And if you have time to spare, also I would recommend you to dig into the code. For example, starting from config, starting from routes, just try to understand what are the resources, like what are the pages that's implemented here. Then take a look at the controllers, and then check the models and views and see how the things are implemented. And in fact, if you finish the first practice, which is the Hello Rails, you should actually get somewhere pretty close to what we have here, which is the Rails intro project. Okay, so that's a quick walkthrough. So you should be able to find all the links here. And yeah, we will then move on to Google Meet. And if you have any questions, concerns, feel free to ask there. But otherwise, it will be your time for the practice. Okay, we will end the stream here and move to Google Meet.